All right, this is, I refer to this as the forest problems. It's really more dwarf fruit trees. And I had to pause and think about how honest I was going to be about this one. This is a really challenging problem for some people, as in I missed it the first time I did it. Okay? As soon as it was explained to me that what obvious, it was like, oh, it makes sense. So it's not that it's hard, it's just that it's not obvious the first time you're going through blocking. After we do this problem, it's going to make a whole lot of sense. So students are designing an experiment to compare the productivity of two varieties of dwarf fruit trees. The site for the experiment is a field that is bordered by a densely forested area on the west or left side. So we see that right here, we have the forest here, and here's another blocking scheme. The field has been divided into 8 plots of approximately the same area. The students have decided that the test plots should be blocked. 4 trees, 2 of each of the 2 varieties, will be assigned at random to the 4 plots within each block. So we're going to put 4 trees here, 4 trees here, or 4 trees here, and 4 trees here. All right? So the field has been divided in 8 plots, approximately the same area. 2 blocking schemes shown below are under consideration. For each scheme, 1 block is indicated by the white region and the other block is indicated by the gray region in the figures. It doesn't really matter as to the white and gray, it's just that's the way they block. So here's a block and here's a block. So if we have block A, we have, for lack of a better phrase, I'll say vertical blocks. If we have blocking scheme B, we kind of have a group of 4, a box of group of 4, and here we have another box of group of 4. Which of the blocking schemes, A or B, is better for this experiment? Explain your answer. So the nice thing was they gave a lot of extra credit if you back this up, but I missed it. Remember, when you block, you want to block so that each block is as similar as possible. So, in this case, if I look at this block, every single one of those plots has one thing in common. They're next to the forest. That's similar. When I look at this one, this block, everything has one thing in common. They're away from the forest. So blocking scheme A is better. And I'm going to draw this out for you in a moment on a separate sheet of paper. Here, we have 2 that are against, in this block, we have 2 that are next to the forest, and we have 2 that are away from the forest. Here we have 2 that are away and next to the forest and 2 that are away. So these blocks are not similar, whereas this block right here, everything's next to the forest, which is similar. Everything is away from the forest. So that's similar. All right, so block A should be homogeneous in regards to a known variable that impact the study. In other words, you don't like the word homogeneous or homogeneous, use the word similar in regards to a known variable that impact the study. What's the known variable? Well, the forest. We don't know what's going on in the forest, whether the animals come out and eat all the dwarf trees, or whether it blocks the light, or whether the soil is better. We have no idea. Because of the plot's proximity to the forest could have a significant impact on the trees, I would choose blocking scheme A. Blocking scheme A is homogeneous in respect to a block's distance from the forest, or is similar in respect to a block's distance from the forest. One block is adjacent to the forest and the other is not. Blocking scheme B is not homogeneous in respect to a plot's distance from the forest. As such, each block has 2 blocks that are adjacent and 2 that are not adjacent. All right, part B. Even though the students have decided to block, they must randomly assign the varieties of the trees to the plots within each block. What is the purpose of randomization in the context of the experiment? The purpose of randomization is always the same. to account for or minimize the effect of variables that were not directly accounted for in the design. We directly accounted for the forest by blocking on the forest, but there are a lot of things we did not block on. So the purpose of randomization is to equal out the effects of uncontrolled for variables. That is a great way of phrasing that. That might impact the fruit trees, such as the variation in soil hardness. You need to come up with something. Make it up. I said soil hardness, moisture content, or the amounts of nutrients in the soil, so that no one tree variety is favored over the other. The random assignment prevents the researchers from biasing the result by preventing them from placing one type of tree in a manner that would favor them over the other type. It prevents other variables from being confounded with the tree type. Now, pause this recording.